Hello, I am Mrs. Anjali Nadgouda, lecturer, Department of Chemistry, KLS Gokte PU College of Commerce and Science, Belagavi. We are in continuation with same unit number 1, some basic concepts of chemistry. This is video number 3. See, in last class we have studied about the matter. What is mean by matter? Anything that occupies space and having some mass, right? So this matter having is having unique characteristics or properties. Okay. For example, if I am holding a pen in my hand, so by observing the pen, what you can tell me about that pen? Yes, you can give its color, right? Yeah, you can measure its height or length, right? Then if it is the testing substance or eating substance, we can take its test or we can smell it, is it? So color, odor, taste, etc., or length, all these are the unique properties, right? So every matter or every substance has unique properties, and these are classified in two categories, right? Okay, so what are these? First one is physical properties, and second one is chemical properties. Okay, what is meant by physical properties? The properties which can be measured or observed without changing the identity or the composition, means without doing any change in the given substance. Example: color, odor, melting point, boiling point, density, etc. And what are chemical properties? Suppose if we pour an acid or if we dip that substance in base, whatever changes occurs, or even if we burn that substance, then there is a change takes place in that substance. So these properties are called as what? Chemical properties. So the properties which can be measured or observed only on allowing the substance to undergo a chemical change. Example: acidity, basicity, or combustibility, etc. Combustibility means burning in presence of air. Now, many properties of matter, such as length, area, volume, etc., are quantitative in nature, means we can measure that, and for this measurement we need some unit, is it? So, what type of unit we can use? Let us take an example of table. Okay. So, to measure its length, we need the meter scale. Is it? Even we can measure that same length by using the foot scale. Is it? Or we can measure by using the tailoring tape, or we can measure it by using the centimeter scale. So we have different methods to measure one length, is it? But these measurements are not accurate, is it? So there is always some error occurs or some difference comes between the measurement, is it? So to avoid this, there is a standard system made in 1960, and this is called as SI system, that is International System of Units. So in French it is called as Le Système International des Units, and it is short form of this is SI system. So this SI system has a 7 basic units, that is fundamental units, okay, of 7 basic physical quantities. Now, this system allows the use of prefixes to indicate the multiples or submultiples of a unit. Means for the measurement of any property, we need value as well as its unit, right? And the multiples are shown with the prefixes. So how it is shown, that we will see in next slide. Just go through this table. Base physical quantity, I told you there are 7 base physical quantities. Then symbol for quantity, name of SI unit and symbol of SI unit. Okay, so first one is length, symbol is small l. SI unit is meter and symbol for SI unit is small m. Okay, then mass, symbol for quantity is small m. Then SI unit is kilogram and it is shown as kg. Then time, so it is shown with t, small t. So these are the symbols for quantity. Remember, don't get confused between the symbol for SI unit and symbol for quantity. Okay, time is shown with small t, the SI unit is second, and the symbol is small s. Then electric current, which is shown with I, capital I, which is measured in ampere, and SI unit symbol for it is capital A. Then thermodynamic temperature, which is shown with capital T, right? Okay. Then SI unit is Kelvin and the symbol for SI unit is capital K. Then amount of substance, how much amount is given, that is shown with capital N. Name of the SI unit is mole and symbol for SI unit is MOL. Okay. Then luminous intensity, it is shown with IV. IV means luminous intensity. Okay, which is SI unit for this is candela and symbol for this is CD. So these units and these quantities you must remember. So by these quantities, because this, based on this, the whole chemistry, or even we can say physics also depends on this. Okay, study of physics and chemistry depends on this. And in chemistry, maximum we are going to use is amount of substance, that is mole. Okay, so just revise this part. Let us go to the next slide, which shows the measurement, how the prefixes are used for these 7 fundamental quantities. Okay, now prefixes used in SI system. See here, these are the multiples in the power of 10. So 10 raised to 1 is called as deca, symbol is DA. Then 10 raised to 2 is hecto, 10 raised to 3 is kilo, 10 raised to 6 is mega, 10 raised to 9 is giga, 10 to the power 12 is tera, 10 to the power 15 is peta, 10 to the power 18 is exa, 10 to the power 21 is zeta, and 10 to the power 24 is iota. Okay, even there are negative multiples, that is negative 10 to the power. Okay, so if multiples are negative, which prefixes are used? 10 to the power minus 1 is deci, 10 to the power minus 2 is centi, 10 to the power minus 3 is milli, 10 to the power minus 6 is micro, 10 to the power minus 9 is nano, 10 to the power minus 12 is pico, 10 to the power minus 15 is femto, 10 to the power minus 18 is atto, 10 to the power minus 21 is zepto, 10 to the power 24 is yocto. Okay, students, even these two charts are required whenever you are calculating something, and to write the multiples you need all this, or even to convert from one unit to other unit you need all these prefixes. Okay, now let us go to the next part, that is which are the units, which are the quantities. Let us take first the example of mass and weight. This is the very common word we are using in our day-to-day life. We consider that mass and weight are same, or similar, but there is a very small difference. What is meant by mass? Amount of matter present in a substance. Means if you take a chalk, let us take the example of chalk, and if you keep it in balance, you will get its mass, right, by adjusting the balance correctly. So this shows how much amount of chalk is present. Okay. And what is weight? The force exerted by gravity on an object. So whenever we are standing on the surface, there is a force which pulls us on the surface, right? So this is called as gravity, and this force exerted by the gravity is called as weight. Okay, so there is a difference between mass and weight. Mass of substance is constant, whereas its weight may vary from one place to another due to change in gravity. And this, I think you have learnt in your school age, that our weight is different on earth surface and on moon surface, right? Because there is no gravity on moon, is it? Yes. So mass can be accurately determined in the laboratory by using an analytical balance. You can refer the textbook to see the diagram of analytical balance, page number 6. Or even nowadays uh, we can measure the mass by using the electronic balance also, very easily. What is SI unit? We have already learned SI unit of mass is kilogram. But can we use the same thing in laboratory? No, we cannot take that much quantity for the experiment, and we are taking very small quantity, that is either in gram or milligram. That is, smaller fractions are used in laboratory to do any reactions, right? So here is the conversion shown. 1 kilogram is equal to 1000 gram. Now you may feel it is very easy because you have already learnt in your school age, but still for calculation it is required, and whenever we feel something easy but we get confused, right? So please write down these all units. Now how to calculate the volume? Volume is nothing but what? Length into breadth into height. So all these are measured in terms of meter. So meter into meter into meter is nothing but meter cube. So what is the SI unit of volume? It is meter cube. Okay. So this is how, by using the basic fundamental quantities, we can derive the other quantities, and these quantities are called as what? Derived quantities or derived units. For example, volume or density, etc. Now, can we use liter for can we use meter cube? We are using always liter instead of meter cube, is it? So but is it possible every time to use the quantities of liquid in liter every time? 1 liter, 2 liter, 5 liter? No. We are using very small quantities, and therefore we are using the different units, that is ml, right? So these are smaller units, is it? So how to convert this? So common unit is liter, and 1 liter is equal to 1000 ml. Now, whenever we are showing this, we are using centimeter cube or decimeter cube instead of ml or liter. Okay. Now, 1 liter is nothing but what? 1 decimeter cube. And ml is nothing but what? Centimeter cube. So 1 decimeter cube is equal to 1000 centimeter cube. I hope you have used many times the unit cc. Is it? Cc means what? Cubic centimeter. It is nothing but centimeter cube. So again, these conversion factors are required for solving the problems. Okay. So we have seen what is the SI unit of volume, as well as we have seen the smaller units used for volume, okay, and their conversion. Yes. Now, how the volume is measured in chemistry lab. So there are different devices which are used. The first one is called as cylinder. So this is, we can, these measuring cylinders or graduated cylinders may be of 50 or maybe of 100 or maybe of even 1000 centimeter cube. Okay, so there is a graduation, means numbering done on this. Then this is, all of you have seen, this is a syringe which is used for especially injection. Is it? Even this is graduated, if you have seen 5 ml or 10 ml, which we call it as 5 centimeter cube or 10 centimeter cube, even of 2 centimeter cube. Is it? Then this is one more device called as burette, which we are using in practicals. Okay, so by this we can measure from 0 to 50 or 0 to 25. Is it? Then this is, another one is pipette. Okay, so by using this we can measure the volume of 10 ml or 25 ml or even of 50 ml. Okay, then one more is volumetric flask. Even by using this we can measure the solution and we can prepare the solution of definite quantity, because these volumetric flasks are of different capacities. Okay, so this is just the pictorial form of the devices. Okay, now let us go to the another unit, another quantity, that is density. What is density is? Density is nothing but mass per volume. Now we know the unit of mass. Mass is measured in kilogram and volume is measured in meter cube. Is it? So these are SI units of mass and volume. Now when we are writing the formula of density, that is mass per volume, the SI unit become kilogram per meter cube. Is it? But the smaller unit used for density is gram per centimeter cube. So instead of kilogram we are using gram for mass, and for volume we are using centimeter cube. So what is the another smaller unit of density is gram per centimeter cube, whereas SI unit is kilogram per meter cube. Okay. Then let us have the another quantity, that is temperature. See, many times we feel fever, means our body temperature increases. Is it? So how we can recognize this or how we can find this? By using the thermometer. Is it? Have you seen the measurement? Have you seen the graduation or the numbering on the thermometer? Yes, it is always there in degree Celsius or degree Fahrenheit. But the SI unit we have learnt is Kelvin. Is it? So there are three common scales to measure the temperature. Either degree Celsius or degree Fahrenheit or Kelvin. Kelvin is the SI unit. Right? Okay. So we will go for next. Here is the diagram of thermometer, which shows you in which unit it is used. This is Fahrenheit, right? So our body temperature comes as 96.6 degree Fahrenheit, right? Then this is Celsius. In Celsius we are getting 37, nearly 37 degree Celsius. Okay, so boiling temperature of water is even shown in all this, and freezing temperature is also shown in this. Okay, now how to convert from one unit to other unit? That is relation between degree Celsius, degree Fahrenheit. So degree Fahrenheit is equal to 9 by 5 into degree Celsius plus 32. This is By using this relation, we can convert degree Celsius to Fahrenheit or degree Fahrenheit to degree Celsius. Yes. Now, how to convert degree Celsius to Kelvin or Kelvin to degree Celsius? So, for this, the relation is Kelvin is equal to degree Celsius plus 273.15. Okay. Normally, for calculation, we are taking 273. So, if we add 273 in degree Celsius temperature, we will get the temperature in Kelvin. Okay. Now, what you have observed in this? In Fahrenheit, there is a negative temperature below zero, right? In Celsius scale, even there is a negative temperature. But have you observed in Kelvin temperature, is there any negative number? Not at all, right? So, in Kelvin scale, negative temperature is not possible, right? So, let us revise the points which we have seen in this class, that is properties of matter with example, then 7 basic physical quantities and their units, then prefixes used in SI system, and conversion from one unit to another unit. Okay, so please note down the points and please read the textbook once again. Thank you.